Hello everyone. Today we're going to talk about selecting the right microcontroller for your application. Few of the key aspects to look out for, and in the later part of the tutorial we're going to select our microcontroller based on a selected requirement and kickstart with it. So let's get started. Before we begin, a small disclosure. All the techniques I mention here are my personal opinion and they are not de facto industry standard for selecting the microcontroller.
Can you hear my voice?
Overall, there are four key aspects to look out for during microcontroller selection. To start with, number of GPIOs and peripheral availability. Always ensure that you have buffer IOs and peripherals in the microcontroller selected based off your requirement. So what I mean is that if your requirement needs you to have 20 GPIOs, always select a microcontroller which has 30 or 40 more free GPIOs. And similarly, like you have a requirement for one UART or one SPI protocol, go for a microcontroller which has more than one UART or more than one SPI. A general rule would be like get a microcontroller with at least two UART or two SPI protocol. This would help you during future scalability where you would have a requirement to interface new external peripherals which communicate over UART or SPI. The next key aspect to look out for is the availability of evaluation board. Always ensure that you have evaluation board for the part you have shortlisted, or at least there is an evaluation board for the series of the microcontroller you have shortlisted. The advantages of having an evaluation board is that you would get to try out the code way in advance before you go ahead and prototype your board with the microcontroller shortlisted. And if there are some erratas or some other issues in the controller, they would be found way in advance and would avoid unnecessary production cost. And in best case scenario, if the evaluation boards has all the IOs exposed, you could realize the entire prototype or the circuit needed in your protoboard on the evaluation board and have the firmware ready way in advance before the actual prototype board is available. Moving on, the next key aspect to watch out for and one of the most neglected is the availability of good IDEs and libraries. Always prefer to go with an IDE provided by vendor. There are key advantages of doing this. One is most of these IDEs are free and vendor would have customized these IDEs to support all the selected microcontrollers from their specific vendor. They would have already integrated all the necessary libraries and with a good RTOS support integrated into the IDE. You take standard vendors like STMicro or NXP, their IDEs have all the tools or all the libraries pre-built or pre-integrated so that when you create a project for the specific microcontroller, you can rest assured that all the necessary peripherals are already active. It's just that you have to add those components into the project and build them. If you decided to go with IDE different than what is provided by the vendor, ensure that there's IDE supports that microcontroller. Also, the vendor has provided necessary drivers and even high-level protocols or high-level application layer if possible. This could range from simple drivers like UART, SPI, USB to a little bit higher layer like a stack for Wi-Fi, Bluetooth module, or moving to the application layer, you could find libraries provided by vendor for graphics application or any other communication stack. The final key aspect to look out for is the technical support. This can range from a support forum to a field application engineer. In a support forum, you can post in your questions or queries, and anybody from an internal support team of the vendor or a third party contributor can help you out resolve the issue, or have a FAE dedicated by the vendor to help you out in person. This is especially useful when you have a tight deadline and you are either having an issue with the hardware or any library related bugs.